Hello, I'm Ehsan. In this video, I want to show how we can read, write, or update or remove and create new folder in microSD. And I prepare the document and I want to show this document at first and then make project. What is generic FAT file system module? FATFS is a generic FAT or exFAT file system module for small embedded system. The FATFS module is written in compliance with ANCS and completely separate from the disk I/O layer. Okay, you can see that we have different protein here. And this is the pinout when you use microSD. Uh, we have 8 pin. You can see that 1 to 8. And the pin and SD and SPI. This is used. But I use the module to read with STM32. Okay, this is SD card reader module. You can see that we have 6 pin here, CS, SCK, MOSO, MISO uh, for SPI and uh, VCC and ground for your connection to micro. Next, explain about the project. As you know, the first file library ST for Mr. Chan, and I want to some changes in it and make a project with that library. We have application interface, file access system. We have a lot of function for read or write or use SD card, and you can see that in here. And I used 7 or 8 function, and I think so. We have 30 function. We can use everything with microSD, same as OS. I mean computer. Okay, file access is F underline open, open or create a file, F underline close, close and open the file, F underline read. I use that highlight in my project, and F gets read the string, F puts write a string, and F size gets size. And the other one is directory access is for direct for folder, open F underline open dir, open a directory, close and open directory, and so on. You can see that here. Find then the directory management, F underline only remove a file or sub directory, F underline mkdir create a sub directory, and volume management and system configuration. A fundamental is really important when you use a driver mount or area of a driver. You must use F underline mount in here. And the next part, media access interface. Since FATFS module is file system, their independent platform and storage media is completely separate from the physical device. And so on, if you want more information, you want to see that and read it. And a storage device control, this is really important. We change this storage device controller in my project. Disk underline status, get device status. Disk underline initialize device, disk underline read data, disk underline write data, and disk IOCTL control device depend function. We change this function in our library. Real-time real-time clock, we use timer indirect in my project, and I will show you what happened. Get underline fat time, get current time. This is the schematic of my board, and I want to add something to this. I use the CP2102 to transfer data on UART and we can see that the terminal, for example, uh, PLC test or Hercules platform. This is it. This is really summarized. And if you want more information, go to LELM library. It's the foresight for Mr. Chan. That's started to explain widely. And if you want more information, you must need this site and visit this site. Is really helpful. Okay, without any waste time, make the project. Okay, choose the access to SU selector. I use this micro C8. Okay, then go to system core, system, debug change to serial wire, RCC high speed clock change to third one. Next, go to the connectivity. I use SPI1. Mode is full duplex master. And change prescaler for baud rate to 8. And you can see baud rate is uh, like this, but when I change the clock configuration, I will show the changes here. Okay, everything is alright. Go to UART1. Mode is asynchronous. Okay, mode is asynchronous and everything is okay. Then go to middleware, FATFS, tick user defined. Okay, go to use LFN and set as enable with static working buffer on BSS. Okay, this parameter is changed, and the last one, maximum SS change to 4096 is high speed of, you can use that. And go to clock configuration, choose the second, change the PLL to 9, okay, and then third one, change there to prescaler 2. We have 36 for PCLK1 in timer 1. I mean so. And go back to this part. I use UART, SPI, and we need to chip select. I output this pin for chip select PB0. Okay, everything is okay. Well, go back to SPI and I will show that what happened. Okay, this 9 megabits per second is really important. This is the number is really important. It changed that. Everything is okay. Go to project manager and use that. For example, SD, the name of project. Browse to choose my file to save this project. And okay, everything is all right. Generate. Open the project and let me write there. Okay, go to maintenance. Add two library in our project. This is the place I save my project. Go to core inc4.h header and add and core and str4 .c. Okay, go back to Kale, right click here, add group. For example, change the name to Leap. Okay, then right click, add existing file to group 1. Go to where you save your project, SD card, SD core, SCR, and add this file to project. And you can see that I add this file. Then click here, see that .h file, and next go to application user FATFS target and user underline disk io.c, open it, and after that open the STM32 F1 cross underline it.c. Okay, we must change this part, user underline disk io.c, to this part. Before I write this project, I compile that code, and I want to copy that code to this project, and this is the last project and this is the new project. Go to user.c, both of them, and I explain copy this file to this project. Okay, in line 85 and 86 you must copy this code and paste in here instead of two line 85 and 86. It's for initialize, and I explain what happened because we in FATFS on the st.h file we use this name and we must change the output and the return of this function. Okay, go back to the next one. Initializing complete. Next is status. Copy this file and okay, paste, and then is user read. Okay, and change it. The next one is write. Copy and delete this one. Okay, and the next one is IOCTL. This is the return or output for this function. I must change to optimize this library as you use in your code. Okay, I see everything is okay. I change this part. You can see that. Change this part in user underline initialize. After that, change this part, user underline status, this sentences or code. After that, user underline read, change this part, or add this code in here. User underline write. Okay, change again this part, and IOCTL change this part to the user underline disk io.c. Okay, go to the it.c and let's show you in last project. Okay, go there, top of them, and compare with them. Okay, go to this part. Okay, we must copy this part to user begin 0. Find that user begin 0 and copy that. After that, go to sysdig, find that in our code, go to sysdig handler and find this part and add to the code. Where is it? Okay, sysdig handler in here. Add this. This is for timer. Somehow we write the code for timer, but I'm never using CubeMX. And that's it. Go back to the main and add this code, and I will explain what happened, but I at first I need to add this code to on my code. This is a project. Okay, in user begin 0 in main.c, we must use this variable to user begin 0. Okay, go there, add this part, and the next is begin 2. Okay, let me copy this code under here and paste in here. Begin 2. Okay, before you compile your project, go to option for target, debug, setting, flash ticket here, reset and run. Okay, and go to C and C++, change optimization level 3 to 0. Okay, and then compile this code. It takes time. Be patient, please, until we have response for K. Okay, we have 0 error and 10 warming. 10 warming is not important. And I want to explain what happened. At first, I add some variable in to library fs for fatfs or file system, fil for file, f result or in the same f result. You can see that. I define a char buffer, then 24 to store data. I define uint because in this library somehow we have interchanged br for write read and bw for write, file read and write count. Capacity is for the capacity of microSD. I define the pointer of pfs, keyword, and total and free space. Then I write the function for send the UART data. You can see that this is the function for send UART. And then the function for buffer size. When we transfer data in UART, we must use buff or buffer, and we know about the size. After that, the buff size, we use the buff clear to clear the buffer in every compiled word. And then this is the line I wanted to explain what happened in here. F-handle and mount, when we use for disk or hardware, we must choose the area we work at. And the pointer file system, parameter 1 is pointer file system, parameter 2 is pointer of null, and parameter is is that optional. When we use 0 is not mounted, and when we use 1 is forced the mountain. Okay, this is the initialize the microSD. After that, we use this function for the size of the microSD. This is really important. I check this library when you use microSD under 10 gig. This library is really suitable, and upper than 10 gig, these libraries have a problem. This is really important, and be careful about that. And then the following operation is using puts and get. Yeah, we use puts and get to write and read data on SD. You can see that at first we open and then we use the puts for write something on SD card and then close and then your data and see that the terminal. After that open again, F gets for read something from the SD cards, and parameter 1 is pointer to read buffer, parameter 2 is size of the read, and parameter 3 is open pointer to open the file. This is the format for puts and gets. After that, close and buff clear. When we write or read something, at first we open, then write, and then close. Then I use F underline write and F underline read as the same uh, write and read at same as puts and get. These two function is not different. At first I open the file and then write in it and send in UART. I see it in my laptop, and after that close, buff clear, and open the file again and read it and send UART buffer and close and buff clear. We have updating an existing file. This is the function we use the last file uh, repeat again or update. We use f underline open flseek. This is really important. It's a function we must use as updating an existing file and puts in write something on it and then open and read and buff clear. This is the removing file from the discovery. The function is f underline undic. This is really important. Uh, File 1 and file 2 is completely removing this file. And the last one is I comment here, create a folder and write to in it. The function is f underline mcdir. This is really important, the function. You must use this function to write, create a file and write on it. Okay, at first, let I show you what's happened. Uh, this is a SD card and this is MPT, and I again with the SD formatter format this SD card. And this is a suggestion for SD. Okay, format. Okay, and I will show you again. We don't have nothing in SD card. Okay, before I compile this code on my board, I want to show my board and my schematic. Okay, uh, this is the SD card reader module. As you can see that, this is my board, and this is the CP2100 to connect it to serial port UART to computer. You can see that I use this to connection with UARTs. Okay, uh, back to the code and compile this code. Okay, I format the microSD and put into microSD card reader. Let's compile it. At first, we must choose a terminal, for example, Hercules. serial. This is the ports. Open it, then compile this code. Okay, SD card is mounted successfully. This is the size of SD card is near to 8 gig, and file text created and is written. This data is from the first file, the file 2 txt created and data is written. This is file 2 is self-study electronic engineer. This is the name of my channel, and this is the update. You can see that this part is again uh, repeat. Okay, at first let me show that what happened. This part is for mounting. This is for uh, area or space of or capacity of SD card. This is the puts and gets function for read or write for fresh file. And you can see that I write and then read this file. Okay, and the next part I use f underline write and f underline read for again read and write for file 2 txt. This is the uh, I write in it. You can see that in here. Okay, and then I updating existing file. I the address is file 2, and again file 2 is repeated. Okay, and I put out the SD card in the module and insert it to my laptop, and I show you what happened to SD cards. Okay, I enter it and go to this part. Oh, we have two file and the format is txt. First file is this data is the from file, is the first file, and the second part is this data is file 2 and it shouldn't be update. Okay, we can write and read it as you can see that. Okay, uh, I want to say something. If the change here to, for example, PDF or DOC, you can see the format of the file in the PDF file, or doc is related to the Word file. You can see that instead of the TXT. This is really interesting for me. I tasted. And last one, I was to remove two file to SD. Okay, I uh, put out the SD card again and insert to the module SD card reader again, and compile it again, clear this window and compile to the board and see that what happened. File 1 txt remove and txt remove. Okay, I will show what happened in SD card when I use remove function. I again insert the SD card to my laptop, and we don't have nothing in here. All thing is remove. And the last one is about creating folder. This is about creating folder. Let's say comments to line here to show you how to create the folder. Okay, removing is finished, and the create folder is used as my code. Okay, I insert again SD cards and compile this code and build. I don't use words, and the result I show you in my laptop. Again, I insert SD card to my laptop Okay, go to the SD card and you can see in my folder, this is the name, and we have the txt file, and this I write and we can read it. This is all for the micro SD card reader module. Thanks for microcontroller tech canal. And if you want download this code, please send me message and I upload this code to Google Drive. And thanks for watching me. Please subscribe my video. Bye.